Hi everyone. Today's goal is to graph absolute value functions. Just a little reminder, a domain is very simply put as what numbers you can substitute in for x. And our range is what answers you get when you solve a given equation, or in other words, what your y becomes. When we graph absolute value equations, every equation with absolute value is going to be based off of something called a parent function, which is a very simple equation where y equals the absolute value of x. Now, in order to graph it, you want to pick some values for x. Always pick positive and negative, and I like to always include 0, and then see what you get for y. -2 absolute value is 2. -1, the absolute value is 1. 0 would be 0. 1, absolute value is still 1. And 2 is also 2. Plot the points, and this is what you get. Now, on all the graphs that you're going to see in this demonstration, the scale is not written in, but each box is equivalent to 1. And you'll notice on the absolute value equation that we have a V shape. The point where the V meets is called the vertex. And as it goes off to the right, up 1 over 1 for our slope, it's going to be the same in the opposite direction on the other side of the vertex. Okay, so we're going to be going over to the left, up 1, over to the right, up 1. Now we're going to take that parent function of y equals the absolute value of x, and we're going to put a number in front of the absolute value. For this case, we're going to put in -2 times the absolute value of x. We want to make a chart again. Substitute in your x values. Pause the tape, see what you get, and then come back. These should be the answers that you got. And when you graph it, you're going to plot your points, and this is what your graph should look like. Now you're going to make another chart, and this time you're going to say y is equal to 2 times the absolute value of x. Again, you want to use the same values. Make another chart, pause the tape, and graph it. Come back and check and see what you got. Here's your value of answers for your chart. And here's what the chart looks like. The graph looks like. Do you notice the difference? The purple one is y equals 2 times the absolute value of x. The blue one is y equals -2 times the absolute value of x. The A will indicate whether or not your graph opens up or down. If A is a negative number, it will open down. If it is positive, it will open up, and it will look like the letter V. Now we're going to do something similar, except instead of having a number in front, we are only going to have or subtract a number inside the absolute values. And I just said we don't have a number in front, but in reality we do. And that number is actually, drum roll, +1. So now let's take a look at the first one. Y equals the absolute value of x plus 2. Here's our parent function, so we can see how that moves. And our last one, y equals x minus 2. Okay, see the difference between the two equations. You want to make yourself a chart again for all three, and then graph them. You can sketch them right into your notes. Stop the recording, work it out, and then come back and see how you did. Our first one should have had your answers here. You know, your second one, and finally your third. Your graph should look like this. Here's the first equation, the absolute value of x plus 2. Our parent function, y equals absolute value of x, is in red. And finally, y equals the absolute value of x minus 2 is in blue. What effect does adding or subtracting a number have on your graph? H will translate your graph to the right or left from the parent function. So anytime you add or subtract anything to x inside the absolute value, your graph is going to shift either left or right. Now we're going to change it a little bit again. I want you to do the same thing, except this time, here's your equations. We're going to change the variable k at the end. First, we're going to subtract 2. Here's our parent function. And then we're going to add 2. Make your charts. You can already see the equations. And let's see how you do with this one. Here's the values you should have received. And again, here's what your graph looks like. The green one matches up to the absolute value of x minus 2. The one in the middle in black is our parent function, y equals the absolute value of x. And the last one in purple is y equals the absolute value of x plus 2. And again, notice how your graph shifts. So k is going to translate your graph up or down along the y-axis. If k is negative, your graph will shift down. If k is positive, your graph will shift up. And sometimes these transformations don't always happen individually. They're combined. So here's a case where we have y equals 2 times the absolute value of the quantity x minus 4 plus 3. The blue is our parent function. Okay, y equals the absolute value of x. A positive 2 means that our graph is going to open upward, and 2 actually indicates the slope. X minus 4 plus 3. The plus 3 means that we're going to shift this parent function up 3 points on the y-axis, and the negative 4 means that we're actually going to move it in the opposite direction to the right 4 spaces. 2, 3, 4. Okay, that would be our vertex, our point of the V. Okay, here's some general rules, and it's basically going to summarize almost everything we just went through. Your parent function is always y equals the absolute value of x. The graph of y equals a times the absolute value of x minus h, absolute value again, plus k has the following characteristics. The graph has a vertex of h comma k and is symmetric. That means the point of the V is going to be whatever number's here for h, and just be careful with the subtraction sign, and then whatever value you have for k. And symmetric means the right side's going to look just like the left side, but it's going to start at the value h comma k. That'll be your x and your y value. The graph is going to be V-shaped. It's going to open upward if a is greater than 0, and it's going to open downward if a is less than 0, or a negative number. H tells you which way to move the graph along the x-axis, right to left. If your equation shows the absolute value of x minus h, you move the graph to the right h units. If your equation shows x plus h, you're going to move the graph to the left h units. The k portion tells you which way to move the graph along the y-axis, up or down. So if your equation shows plus k at the end, you move the graph up k units. If it shows minus k, you're going to move the graph down k units. Okay, so here we want to graph this function. If we look at a is a negative number, so it's going to open downward. Our vertex, the point at which we're starting, is going to be -2, 3. Remember, it's opposite in here. Okay, so we're going to go to -2 up to 3, put a point. The graph opens downward. And, oh, sorry about that, the slope is 1. So we're going to go down 1, over 1, down 1, over 1, down 1, over 1. Draw your line. And since it's symmetric, we're going to do the same thing in the opposite direction. Okay. This time we want to write the equation from the graph. Our graph opens upward. And I'm going to apologize because I'm missing a number 2 here. We're actually moving up 2 over 1, so our slope should be 2. Let me just draw that in for you. Sorry, guys. So our A is actually 2. Our vertex is at 0, 3. So our H is 0. So we would have the absolute value of x minus 0, which is the same thing as the absolute value of x. And then our K, our shift on our y-axis, is -3. So we're going to just add a -3 on the end. Another kind of function or graph that you may run into is called a piecewise function or a step function. And for that kind of function, it has different rules for different parts of its domain. So depending on what numbers you pick for x, it's going to have a different rule or a different equation for part of that. So here's an example of what one may look like. When x is greater than or equal to 0, the absolute values of x is going to be equal to x. When x is less than 0, the absolute value of x is going to be equal to -x. Step function pairs every number in an interval with a single value. So it's still a function. You're still going to have one value for x, and it's still going to match up to one value for y. Each piece of the graph, though, is going to be missing an endpoint marked by an open circle. And this is what they look like when you graph them. The reason we have the open circle here is because this number, -1, actually belongs to this part of the rule up here. 0 is going to be an open circle because the answer to 0 is actually going to be part of this answer.